please give a very warm welcome to Markus from Xella.
Thanks, Matthew. So, hello everybody here in Malmö. I see a lot of familiar faces from last year or 1.5 years ago, but a lot of new faces. Today I want to give you a short lecture. I have only 15 minutes, so I can talk about this topic 4 hours if you want, but I think I will be hated by the organizers. So let's do it in 50 minutes. Here you see our raw materials. This is the secret of Xella. We have only 4 to 5 raw materials, a little bit water. So we heard a little bit today about resource using of water, fresh water we need. We have sand, not the traditional one. We are fighting with the industry of ITU for it because we need special sand with a high silicate content. And we have lime and cement. So these 4 ingredients help us to produce something about 10 million cubic meters of different products here, which are all calcium-based. With these things, we can build houses in all types here. We build industrial buildings. Here we supply the building materials to our customers. We are not a construction company, we are just material producer. But if you look to all these reference buildings, they have one thing in common. We start at the beginning to make drawings in paper form or in digital twins. We calculate the different solutions to estimate the costs. And then we go to the building owner and say, okay, I will build you this house for this price, maybe or maybe not, hopefully in the right time. But then he agreed, and then we start with all the design behind. We make structural design, a very precise way. We're using finite elements, so the digital twin is used here to make a clear structural design, to have all the information of the building, to give the building materials the right performance. The same we are doing from the energetic side. Thermal bridges are calculated in a way you can do it in a perfect way, so there is no waste of energy in the theory. So you see it here. The red is a warm side, the blue is a cold side, so we can bring everything in line. And that's a good thing. We have the computer, we have the information in the digital model. So we can take it out, bring it to different software solutions, and calculate the whole building. Then the offline world starts, so the construction. You have very experienced craftsmen on the site. They know to use the materials. The increase of prefabrication, like Stefan told here, it's a normal way, because the lack of craftsmen, it's really a problem in the industry today. If you are looking for masonry workers, you will not find them in this number we need. So we start with prefabrication, larger elements, up to the size of a wall. But we also invent the process of building. We start here in the Netherlands with the first site with the Hololens. So you don't have drawings on the side, you use the Hololens, and you see the wall you need to erect. So the funny thing, on the fair in Cologne just 2 weeks ago, we have had the Hololens by Trimble here, the first Hololens 2, and the German colleagues, they don't have it because we ordered it in Poland, so it was a little bit faster there. So digitalization is a global thing. And at the end, we have everything in there. We have built a nice house. We have a building pass, an energy pass, so we can hand it over. But don't do it in paper format. The file of a building is today the digital twin. There you have all the information in. And if you use this tool, it's very good. You have the material information in there, the maintenance information, so you can hand over a building to a customer with all information about maintenance. So here also solar power. This is one of the first buildings in Germany, a zero-emission building with electric car, with solar power, with heat water. So If you see today a house or a building, a single family house, it's 70% of technology in it and only 30% of traditional engineering in it. So you must do it in the right way there, and you must give the owner to hand over a digital twin that he understand what he can do with the building, how he can live in it, and there's the truth and the myth you can decide about. You can't open a window in a zero-emission building, but it looks very similar to a standard building. It's just technology you bring in it. But nowadays, it's not only build a house. You must look much more closer to resources you are using there. From the beginning, you saw we have there only a few resources we are needing. But you must find them. And we don't have these resources unlimited. So it's a job of all building producers and manufacturers there to take care to have a source of resources and use it in the best way. So circular economy is one of the buzzwords here. You design the materials, and at the end of life cycle, here at the top, you reuse the materials. If you don't do the urban mining in the future, we will have there a lack of resources for new products. So we are thinking now how we can use the material in 40 to 50 years. There's an obligation in the European Union to use recycling materials. In some countries, it's a must-have. In other countries, you can say, okay, you get better points in LEED or in all these certification systems. But you must do it. So you will do it like an X-ray now. You go much more deeper in the building to understand the material content, to understand everything in there. But this is nothing new. You can have it in paper format. I'm talking now a little bit about lifecycle analysis. The environmental product declaration gives you, in paper format, since almost 10 years, 12 years, the information of all your material content in view to environmental protection. You can get it from a manufacturer, you can get it from associations, but they are all similar. They have a clear structure, a clear content from production to the reuse phase. So it's a whole life cycle of a material. And you must do it now for your materials. It will be in the Green Deal of the European Commission, one part that you must have an environmental product declaration of your material. It doesn't matter what kind of material you are producing, but you will have to declare all the steps there from A to D in the different levels. But be aware, here you can see on the left side the version, the Xella version for our calcium silicate products, and on the right side from the association in Germany for the same product. On the first view you say, okay, well, not so good the product. But if you are doing it just this way and you don't read it carefully, then you compare here apple with pears. Because the problem is there, and this is a big advantage of digitalization, that the units are different in the paper formats. On the left-hand side, you see it's based on cubic meter of material. On the right-hand side, it's on ton of the materials. So you're free how to declare. But in the future, it will be at a similar level, and if you recalculate it, then you compare apples with apples, and you see it's the same value. It's a better value here for the material because we spend a lot of money and a lot of time that we're monitoring our energy consumption. We are reusing material, so we have closed production loops in our factories. There is no waste in the AAC production here, which is originally coming from Sweden. So 80 years ago, they invented here because of the crisis of the wood in Sweden. Nobody can imagine a crisis of wood, but okay, it's the way. And now we have the chance to put all the information in the digital twin of our blocks. So we have the data in the companies. You have the data in your companies about your material properties. You need to add it with the environmental properties, and then you can bring it to your digital twins of the material. A little bit advertisement for BIMobject. They offer it since half a year. You can find it there in the properties that you can put in your environmental product data in the right units. So you have it there, all the same information I showed you on the paper, you have it now here in the digital format. And we decided to make the environmental impact of all our material visible. We have here our digital system on the left-hand side. It's the Xella group, and then we spread the data here from the blue data hub. And we will add, step by step, all information about all material properties for the performance of the materials on the one hand side and then environmental impact on the other hand side. So that you can use it, that designer can use it and bring it in their ideas. This is an example. We have the German Association Products for BIM, where we design a sample building. It's only half of the part. There's an industrial building on the other side. And this is a typical Ytong wall. We have only white building materials. So this is, if you go into a new construction, how it should look like. But behind this wall, there can be many solutions of technical, similar wall solutions. So we have there, I selected only 3 different wall solutions. They have the same technical performance. From the thermal resistance, from the load capacity, and almost from the wall thickness. We are not talking about more than 2 or 3 centimeters different in thicknesses. But if you bring then this to the different models, you can do it very easily. That's a good thing of the digitalization. You change the wall from one type to another type. So we start here with a monolithic Ytong wall, 80 years experience with it. It's one of the best solutions. And this then is a lifecycle analysis for the production of these material. And you see there is a lot of energy in it. We can do the same. It's a calcium silicate wall with a mineral insulation system, our multipore system. So we reduce a little bit the global warming potential and the primary energy use. The same, we can combine Ytong with multipore. It's also working for this building. Now you have a less than 200,000 megajoule here, primary energy. And this is the way how we can do it here. That we say, okay, you make the design of a building step by step at the beginning of a building, and you can see by the design you can save something about 35% of global warming potential. And this is the role of designers in the future, to make decisions based on energy properties and environmental properties. But this is only one part. I show you only here this thing for the production side. Materials have a life cycle. If you compare the 3 versions, the monolithic wall has a duration of 80 years with less maintenance work. If you have an attic system or an FS system, depending on the country, then you need to renew it. You have repair work on it. So the lifespan is only 40 years or 50 years, depending on the system. So if you compare it over the whole life cycle, maybe the first design idea is not the best one. But to decide about the life cycle and the duration, how long you can use a building material or anything else in the building, this is a part we can talk a long time about it, because nobody knows really. But if you don't do it right, it's the same story. You compare Apple with pears. So talking about design, environmental design, means talking about the same situation. And for us, it's our job now to work together to bring all the data we have in our companies, bring it to the public that we can use it, that we can make environmental assessments on the buildings, and to create there a sustainable environment and the future of the building. We can only do it with the digital tools, because then you can calculate the alternatives, and this is something we need to do, because otherwise we will run out of resources, and we need to do it in the best way together. Thank you very much.